oh yeah.
Welcome everyone once again to our live Math Homework Helpers episode. Helping us today we have the very cool Mr. Cook from Honeygo Elementary School and from Baltimore County Public Schools Math Office, the very awesome Mr. Tang. Hey!
Max?
Yeah.
Mr. Tang is from the map office. You said math.
What? Max? Ollie? Ollie.
Yeah.
Mr. Tang is from the math office. The show is all about math, not maps.
What? Wait, that doesn't add up.
What? Ollie, of course it adds up. It's math.
Oh, fine. Okay, well, we'll just compromise and say Mr. Tang is from the mats office.
You know what? I do need a new yoga mat.
Mm-hmm.
Sounds like a plan, Ollie. Let's do it.
Yeah.
The maths office.
Yep.
Max, Ollie,
What?
What?
it's the math office. I work in the math office.
There's a
Max office?
Huh.
You know what, Mr. Tang?
Max.
I think it's best if we just move on from here.
Yeah, that's you.
Yeah, good idea.
Cool.
Again,
Cool.
welcome everyone out there in TV land to another episode of Math Homework Helpers. Don't forget that everyone who calls in today will receive a wonderful, amazing prize pack.
Woo!
That's right, Mr. Tang. The prize for today is a loaded prize pack filled with all kinds of goodies, from calculators and pencils to even some good stuff, also some great things. But it's time to have some fun helping you with your math homework. So give us a call. The number to call is 410-494-1459. That's right, 494-1459. In addition to calling, you can also send your questions in via the YouTube chat. Max, who is our first caller of the day?
Oh, I'm so glad you asked there, Mr. Cook. The first caller of the day is Hayden from Norwood Elementary School. Hayden, are you there?
Yes.
Hey, how's it going, kiddo?
Hey, Hayden.
So, Hayden, what is your math question for us today?
My math question is, there are 10 bikes and 6 cars in the school parking lot. How many wheels in all? Show your work.
Well, Mr. Tang, I think some of those problems might be over there on that paper, too.
Yeah, so Hayden, did you say there are 10 bikes and 6 cars in the school parking lot?
Yeah.
And what was the question that you, what was the question you have to answer?
How many wheels in all?
All right, so we have bikes and we have cars, right? What do you know about a car?
It has 4 wheels.
Okay.
Yep.
So we have,
So 6 cars,
okay,
and each of the cars is going to get 4 wheels to them.
okay.
Do you like drawing a picture, Mr. Tang? What's
Yeah.
easier for you?
Hayden, what do you want? Do you want to draw a picture?
Yes.
Or do you want to
Nice.
see the coolest car ever?
All right.
Oh, Mr. Tang's great at cars.
Not as good as I am with penguins. But
That's true. Oh, look at that car.
Whoa!
One,
need one of those.
2, 3. That's exactly how they look, too.
Exactly.
we might need some windows, though.
Yeah, make it
Yeah.
legit, please. for
Vroom,
sure.
vroom!
Is that a door?
Yep, that's the door.
Yeah.
With a window.
Yep, clearly, it's a window.
Door.
So, what do you know about bikes? How many wheels do bikes have?
They have 2.
2. Okay.
Yep.
Let's draw. Oh gosh.
Oh, look
I
at
think
that
so.
bike. Mr. Tang, you're an artist. Such
We need a
artistry.
little car seat.
They teach you that in the
map.
maps
Bike seat.
office?
Yeah, actually, I learned this in the map office.
Oh.
Oh,
He was trying to find his way, but it didn't work out.
I think it's the math.
All right, so Hayden, we know that we have 10 bikes. Each of those bikes have 2 wheels, and we know we have 6 cars, and each of those have 4 wheels.
Nice.
So is there, Hayden, how do we figure out what the total is for the number of bike tires? What could we do?
We could count by 2s and 4s.
Okay, let's do that. So if we have 10 bikes, we can count by 2 10 times, right?
Yes.
Okay, so if we have 2, do you want to skip count or should we add it up? How do you want to do this?
Skip count.
Okay, let's skip count. Let's skip count 10 times, okay? So we'll start with 2.
2,
Yep, keep going with those multiples.
4,
Keep going.
Good.
6,
6,
8,
8 is great.
10,
10. Keep going.
That's 5. Can we double that, sort of like a ratio table, Mr.
You
Tang?
totally could do that.
Like if that's 5 bikes, Hayden, how could we decide for 10 bikes? If there are 10 tires for 5 bikes, how could we go from 5 bikes to 10 bikes?
we could,
If I take 5 and I double it, what's 5 and 5 together?
10.
Yeah, you got it.
Hey!
So let's double how many bikes are, or how many tires are in 5 bikes. What if we double 10, Hayden?
20.
Yeah.
There
20?
you go.
So we have 20.
Yep.
So with our bikes, we have 20 wheels because we have 10 of them, right? So what we could do the same exact thing with our cars. If we have 6 of them, we can skip count by 4 6 times.
6 groups of 4, absolutely.
So we start with 6. And if we skip count another group of 6, that's 12.
12.
And what about another group of 6?
18.
Okay.
Very
and we
good.
need one more group of 6 after that.
24.
Yeah.
Excellent job.
So we have our 6 cars, and we have 24 wheels. Hayden, are we done?
Let's look back at that question really quickly. Just if you look back at that question, what does it say at the end that we have to do?
Go for a ride?
Yeah.
Oh,
Can we
for
go for a
sure.
ride?
Put
Are
the
you
bike
taking the
on
bike
car,
or are you taking the
drive
car?
the car.
I'm
No, we're
taking
gonna-
this bike.
We're going to do both.
Definitely. I think Max has his license here, so I'm pretty sure that'll work.
Wow.
So Hayden, it says how many wheels are in all? Did we solve that part?
No.
No, not yet. We're close though, right? Because we figured out how many wheels we have with our bikes. We have figured out how many wheels we have with our cars. There's one more step here. Can you tell us what you think it is?
So we need to figure out the total number of wheels. Well, how many?
Wait. Did you say total?
Ooh.
I know that word.
Yeah, what do you know about it, Max?
Well, I just know when you say total, it's like all together, right?
All together.
So Hayden, what do we do?
We add them up.
We add them
let's
up.
do it.
That's what I'm talking about.
We
Man.
have 20
Hayden
and
knows.
24, and we can add them up. So we have, how many ones do we have? We have 4. And how about the 10s? We have 2 10s and 2 10s, 4 10s, which is 40. So all together, how many wheels do we have?
Go ahead, Hayden, tell us.
Hayden,
What did Mr. Tang circle? And point to? With 2 arrows.
He has to have that going on at the same
3
time.
arrows.
He might be on the phone chatting with us with
Oh,
the,
that's true.
oh, that's true.
you
yeah.
know.
So we have 20 and 24. Well, boys and girls, we have 44 wheels.
There it is.
44 wheels.
44.
Hayden,
Nice
say
job, Mr.
44
Tang.
wheels.
That's a lot of wheels. And I
Really?
love I love the different strategies we use because we started with the skip counting, and Mr. Cook said, wait, I know that 5 bikes is half a 10, so we could just double it. So if I have 10 bikes, I'll have double the 10 wheels. So that's where we got the 20 from.
Absolutely. And Mr. Tang decided that it was so much easier to skip count by 6s, and we know that we have the commutative property of it multiplication, so you could do 6 groups of 4 or 4 groups of 6 and still get the same answer.
That's true. We could,
which is awesome.
We could have skip counted by 4, but I think Hayden had a good grasp on his 6s.
He really
and
did.
was able to skip count by 6s pretty easily.
Completely. And that way, now we can see how many wheels total there are.
That's right. And I think Hayden really helped steer us in the right direction on this one. You know
You
what
are so well-rounded. Thank you.
Anyway, thank you
All
very
right,
much.
let's roll on, if you don't mind.
Yes, here we go.
Oh, yeah.
Keep this show a driving. All
Thank
right,
you, Hayden.
Thank you so much for calling in. We got some really cool stuff we're going to send your way, okay, kiddo? Hayden is
Thanks,
speechless.
Hayden.
Bye
Bye-bye.
bye.
I think we have
Bye-bye.
another Norwood
Bye-bye.
friend though.
All right, wait a minute. Ollie, who do we got on the phone now?
Oh, you guys ready?
I'm ready.
On
are.
the phone now from Norwood Elementary is Ida in 2nd grade. Hello.
Hi.
Ida.
Hi, how are you?
Good.
Ida,
Wonderful.
do you know Hayden?
Yeah, this is my
Really?
friend.
Is Hayden in your class?
Yeah.
Whoa,
Cool.
So, Ida, what's your question for us?
We're ready.
It's a challenge.
What's that? Go ahead,
Ben
say.
saw,
Oh.
Ben saw some wagons and trikes on the playground. In all, he saw 27 wheels. How many wagons and how many trikes did he see? There are two possible answers. Can you find both of them? Show your work.
Oh, we got to show the work.
All right. Yeah.
Gotta show
it's-
work.
And showing our work sometimes requires things to be working.
Oh, yes.
You know, so
What's wrong?
hopefully we
Mr.
can.
Cook, did you break it again?
You know what? I tried. It didn't fly out the clubhouse like I thought it was going to,
I see.
but it happens.
Oh, well, that's okay. Look, it's
These are the-
thinking.
They're wheels.
Yes,
they're right
it's
here. They're
wheels.
just showing us how the wheels are turning.
That's right. That's
Um,
right. And it's always important to think because that's how we solve math problems.
Exactly.
So
Wh-
true.
Oh, there it is.
Hey.
It's up. You just got to boot back up. Bring it on up.
Bring it on back up.
Bring it up.
All right, Mr. Tang, do you have this problem?
I would need a refresher on what the problem was.
Ida, can you say the problem one more time, kiddo?
Sure. Ben saw some wagons and trikes on the playground. In all, he saw 27 wheels. How many wagons and how many trikes did he see? There are two possible answers. Can you find them? Can you find both of them? Show your work.
Okay, this is a fun one. So we have two different kind of vehicles. So in the last problem, we had bikes and we had cars. In this one, we have wagons and we have trikes. Ida, do you know how many wheels are on a wagon typically?
No.
So if I'm imagining a wagon, I'm imagining one of those little red ones, what are they called, radio flyers?
Sure.
Yeah.
And
Let's go with that.
they have the little handle on it, and I'm imagining a wagon with 4 wheels. And so you're pulling things along. You can put stuff in the wagon. You can sit in the wagon. So a wagon would have 4 wheels, and then a trike. Do you know how many wheels a trike would have? A tricycle?
No.
Oh, wait a minute, wait. Don't just say it. Think of the word try and think of like triangle.
Ooh, a triangle.
How many sides does a triangle have?
That's a great question, Max.
Thank you.
3.
Yeah.
3. So
Yeah, there you go.
A trike has 3 wheels. So we have wagons which have 4 wheels, and we have trikes which have 3 wheels. So let's see if we're back up and running here.
Well, we shouldn't be running with that. It's very expensive.
Very heavy, too.
Well, we're going to be riding the trike, right?
Maybe you pull it in the wagon.
And
I heard
yeah, I
Mr.
think we'll be
Tang's
safe
giving
in the
wagon
wagon.
rides.
All right.
We're up.
So
Perfect timing.
we're back and running. Mr. Cook, we have wagons and we have trikes, and Ida and the team here, we decided that wagons have 4 wheels and we have trikes have 3 wheels. So in all, he saw 27 wheels altogether.
Oh, so we already know.
We already know our total.
Ah, so we're done. Woohoo!
Right.
Marchese,
That was so
anybody?
easy.
Ida, are we done?
Beautiful wagon.
No.
We haven't even started yet.
We need to figure out, so there's 2 different combinations that we
Right.
can come up with.
Got
so
it.
we have to figure out what combination. Oh, look at that, Mr. Cook. That's
Mr.
a
Tang's got
3-dimensional
some
wagon. I love
competition.
it.
Whoa.
I'm trying my best. I'm triking my best. I'm definitely not going well on the trike, unfortunately. But I'm going to go with a 3-wheel trike. Did anybody else have a big wheel when they were growing up? You know, the big one in the front?
Oh, yeah.
And then they had a 2 in the back.
Yeah.
I thought that would be fun. All right, so how many wheels we got on the wagon, we say, Ida?
4?
Okay.
Right.
So we have 4 wheels, and that's on our wagon. And we said 3 wheels on the trike, right?
Yeah.
And 4 wheels on the wagon. Now, with our total, we have 27 wheels altogether.
Yeah.
So let's say that there was 1 wagon. How many trikes would we have to have in order for that to for us to be able to have the same amount of wheels as 27? Let's see. Well, let's count up by 3s, and let's see if we can get close to 27.
Okay.
We'll try to just get close.
Do you want to do one at a, how about if we have 1 wagon and 1 trike at a time and count, and we can count that way?
And count together?
Yeah, and then when we get close enough, we can see if we need an extra wagon or an extra trike.
Okay. So
So-
I'm going to draw a table. Is that cool?
Yeah, that sounds great.
And then that would be, and then on this side, this will be our total wheels.
Okay.
This is going to be our wagon column. This is going to be our trike column, and this is going to be our total column.
Totally.
So 1 wagon, 1 trike. How many total wheels is that?
So that'd be 4 plus 3.
Okay. Ida, what's 4 plus 3?
7.
There you go.
Okay. So if there were 2 wagons and 2 trikes, we have 8 and 6. 8 plus 6, I think we got 14, because we can double that above it. Now, if I doubled again, I'd get 28 wheels. So I can't double that number again, but I can increase my number of wagons, and I'm going to keep my trike number the same. Let's see what happens here.
So 3 wagons would be 4 plus 4 plus 4, which is 12.
Uh-huh.
And if I have two trikes, I have 3 and 3 is 6. So
Good.
now we're at 18.
18. Can I increase a trike? I think that would be enough, right, to have 21?
Yeah, we could
I
do
think
that.
so. We can't double it. You know what I was thinking? 4 wagons and 4 trikes. So we're up at 18 right now.
So Ida, how many more do we need to get to 27? If we're at 18 now, how many more do we need to get to 27? You can count them from 18.
Well, 18 to 28 would be
7 more?
Well, 10
And
more
one
would be
less.
10 more would be 28. So we need to get to 27, so that's 9 more, right? So we need 9 more wheels to get to our number 27.
We're close.
Ollie, what do you think?
I think I'm hungry.
You're hungry?
Hungry.
Okay.
Yeah.
Okay.
Well,
Just being honest.
let's get on one of these, and maybe we can go get something to eat for Max and Ollie.
Where
Sounds
did
like a plan.
Where did Max go?
There he is. He's back here. He's hanging out. So I think if we were to increase our number of trikes, because we said you needed 9.
9, right?
All right. So let's say I had 3 wagons, and I increased my trike amount. I needed 3 more than my 2 that I have there. So I'm going to have 5 trikes, and I'm going to see what my total is there. Max, can you help me out? 3 groups of 4
Let's
is
see.
how much?
Well, that'd be 3 times 4, which is 12.
You got it. So 12 wheels here. Ollie, I know you're hungry, but help me out with this one.
Okay.
I need 5 groups of 3.
Well, that'd be 5 times 3, which is
Right.
15.
Okay.
Nice, Ollie.
Yep.
Ida, can you tell me what's 12 plus 15? 2 and 5 in the ones place is 7.
7.
And then 1 and 1 in the tens place.
1 and 1.
Oh, 27?
There we go.
Yeah.
Yeah.
3 wagons, 5 trikes. We have a total of 27 tires, 27 wheels.
got it.
Wait, that's the answer.
It is.
So that's one way we can do it.
One.
And another great thing that you can do is if you have a piece of paper, you can do the same thing that Mr. Cook did with the chart, or you could draw pictures of the tricycles and the wagons to see how many wheels you can come up with, how many other combinations you can come up with to get to 27.
Sounds like fun.
That sounds like a lot of fun.
Oh, yeah.
Totally.
Ah!
You
Good job,
are
Max.
adorable. Oh my gosh.
Oh, stop it,
You
Mr.
are
Cook.
with the door.
painstakingly adorable.
You're going to get
Thanks for
stuck.
the call, Ida.
Thank
Ida,
you.
we're going to send some prizes your way. Thanks so much for calling in.
Thanks for calling,
Hey, you
Ida.
guys ready for another caller?
Yeah.
Who do we have on the line?
Bye.
All right, ready? We got Bryce. Bryce, you'll never guess where Bryce is calling from, guys.
Where?
Norwood Elementary
Norwood.
School.
Norwood.
Hey.
Bryce, are you there?
Yeah.
How's it going, man?
I'm doing good.
Wonderful. Did you have a nice day today? What'd you think of all the snow yesterday, huh?
So much.
We didn't get any snow.
I know. It was like a little bit of, looked like, I don't know. What did it look like?
Disappointment.
Oh,
Yes.
Mr. Cook, yeah.
Yes.
We should have had off. You know what I mean?
It's a bummer.
Got to play it safe.
Gotta
It's like
play it safe.
a little bit of like, it's like powdered sugar on the ground. That's what it was. Didn't taste like powdered sugar, though.
No, it didn't.
Not the yellow kind. That was.
What? Mr. Cook, for crying out loud. All right, Bryce, what's your question for us today?
It's number 3. Circle the correct answer with 4 questions: A, B, C, and D.
Cool.
Okay, which one do you want to do?
All of them.
You want to do all of them?
Oh, I like the enthusiasm.
All right.
He's ready.
So A says the 5 in 581 is in the what place? Is it in the ones place, the tens place, or the hundreds place? So Bryce, first thing, let's read the number together, okay? Actually, you read it to us. What's that number?
581.
Okay, 581. And we have to be able to tell what place value that 5 is in. So what do you think? What are you thinking right now?
The HCL chart.
What was that?
Let's go to an HTO chart.
Oh, HTO.
So,
Okay.
yep.
So if we take our number, we know our ones come first, and then we have our tens next, and then we have our hundreds.
Wait a minute. Where did you get the HTO from? Oh, never mind. Hundreds,
It's
tens, ones,
Yeah.
HTO.
Okay,
I'm
so
up with the lingo now.
So that's a good strategy, Bryce. So now that we have that, what can you tell us from looking at that chart and looking at what we did with our number?
So it should be hundreds because the first one is H and it's in the H part.
Okay. So using this strategy, we were able to put this little organizer here and be able to see that it is under H. Another way you can tell is you know that you have your ones, your tens, and then your hundreds, right? So and also when you say the number, you're saying 500, right? 581. So that is definitely going to be your hundreds. Good job, Bryce. Why don't we do one more together? Which one do you want to do?
Let's do the second one.
Second one? Okay. So the 5 in, I'll write the number, you say the number, okay?
358.
Okay.
Good job, Bryce.
358. And so same thing, we have to decide that 5 is in which place value? The ones, the tens, or the hundreds?
The tens.
So what, we didn't even need to do the OTH chart, right? How did you know it was a tens?
Because it's in the middle.
Okay, it's in the middle. So is every number in the middle of any number in the tens place?
That's a good
No.
question. No,
No,
right,
Not
Bryce.
everyone.
So it's in the middle of a 3-digit number, right?
Mm-hmm.
Yeah, because you have your ones, your tens, your hundreds. So that's really good. That's a really good job, Bryce, for you to conceptually understand that if you have 3 digits, you have your ones, your tens, your hundreds. So the digit in the middle would definitely be in your tens place. Awesome job, Bryce.
Sweet.
Awesome job.
Good job, Bryce.
Yeah.
He
Are
read
you-
those numbers really well, too.
Yeah, he did.
And
Bryce,
Mr.
do you
Tang, I
under-
think you're right in
Yep.
terms of saying the numbers is what really tells you which place value they're in.
Yeah.
When you said 50, the only way that a number could be 50 is a 5 in the tens place, because 5 groups of 10, that would be your tens.
Yeah.
There you go.
That,
All right,
that's
kiddo.
great. That's a great job.
Well, thanks so much for calling in, buddy. Have a great night, and definitely call us back next time, okay?
Bye.
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 Man, we've had some great callers so far, guys. What do you
We
think?
have.
We're having a lot of fun here.
Max-
Oh, well,
Absolutely.
guess what? We got a real good one coming on now.
Who's
one,
on the
very
phone
cool.
now?
Who we
Next
got?
up, we got Henry from Riderwood Elementary School. Henry, are you there?
Hello.
Yeah.
Henry, how's it going, man?
I'm doing okay. How are you?
I'm all right. How do you like everything over at Riderwood?
It's great. Great
Yeah.
school.
What's your favorite class? Henry?
Music, instrumental.
Oh, really? What are the odds? That's I heard you got a great teacher over there.
Oh.
So, Henry, what's your question
that's
for us
super.
today?
Well, if you don't mind, I actually have 2 questions.
Sure.
Sure.
Okay, so the first one is Hiko always takes her water bottle when she hikes, and she always drinks half a liter of water every mile she hikes. Yesterday, she hiked 3/4 of a mile.
Okay.
What fraction of the liter of water did she drink?
Wow.
So it sounds like we're working in some fractions here.
Yeah.
And it sounds like we're working with proportions.
Mm-hmm.
Was your original proportion or your original unit rate a half a liter per 1 mile?
Half a liter for 1 mile.
Okay. And so we're trying to figure out the amount of liters that it requires for 3/4 of a mile. Is that correct?
Yes, that's correct.
Okay. So what would be your first step here? How has your teacher talked to you about solving these?
Well, first we're probably going to have to figure out what half a liter. Well, half a liter is 1 of 2. So I think that we would have to do that times 3/4.
Okay. So you're saying what half of 3/4 is essentially. Okay. So because we know that if we had 1 mile, we would drink 1/2 of that. But we have 3/4 of a mile, so we need 1/2 of 3/4.
Right.
Okay. So what do you think? What do you think? And how would you solve this at school, Henry?
Well, our teacher usually says to split something, so instead of 1/2, it would equal 2/1 times 3/4.
Oh, I see what you're saying. So
Which would equal,
are you dividing fractions at the moment, or are you multiplying fractions?
currently we're multiplying.
Right. Right. Okay.
Okay.
So if you were to multiply 1 mile by 1/2, do you agree that you would get a half of a mile?
Yes.
Okay. When you multiply 1/2 by 1/2, what's half of a half?
Half of a half is 1/4.
Excellent. So you have, so now a new rate that we have, it's not a unit rate because it's not per 1, but it's per half right now. We have a 1/4 of a liter is the same as half of a mile. Well, I'm trying to think about a way that I could easily work with 1/2 and 3/4, and I'm still not seeing that yet. So I think I need to go one more, and I'm going to try to figure out what 1/4 of a mile and how much water would be needed for 1/4 of a mile. Well, I can do that by multiplying this fraction by 1/2 again. What's 1/2 times 1/2? We said that that was 1 over...
A half times a half. Wait, let me work this out quickly.
You already told me earlier what 1/2 times 1/2 was.
1/4.
Exactly. So we have 1/4 miles, and whatever we did to the left side of our ratio table, we need to do to the right and vice versa. Whatever we do on the right side, we now need to do on the left side.
Keeping it even.
Keeping it even.
Okay.
Henry, what is 1/2 times 1/4?
1/2 times 1/4
Yes.
is 1/8.
Cool. So, do you agree then that 1/8 of a liter is required to run 1/4 of a mile?
Yes.
Okay, excellent.
Definitely showing good leadership skills.
Now, I need to go from a fraction that works really well with 1/4, and that's 3/4. How do I go from 1/4 to 3/4?
Just move your pencil.
Yeah, just
over.
change the number.
Yeah. There you
You would
go.
have to add
Good.
4.
Yeah.
Add 2/4. So we add the 1/4 two times, right? So it's 1/4 plus 1/4 plus 1/4 would give us 3/4.
Yep. And that's 3 groups of 1/4.
Yep.
And so 1/4 miles times 3 is 3/4 of a mile. And now I need to do that same thing on the left side of my ratio table.
Ratio.
Ratio.
If I know that 1/8 of a liter is equal to 1/4 of a mile, and I need to figure out the number of liters in 3/4 of a mile, I multiply the right side of my chart by 3. I'm going to multiply the left side of my chart by 3. What's 1/8 times 3, Henry?
1/8 times 3?
Yep, 3 groups of 1/8. So 1/8 plus 1/8 plus 1/8.
Oh, it's 3/8.
Excellent.
Very good.
So our ratio table allows us to take our original unit rate and break it down until we have a number like 1/4 that could be evenly shown to become 3/4. And whatever value that was on the left side, we used that same scale factor and got it up to 3/8 of a liter. So that means that it's going to take 3/8 of a liter of water to run 3/4 of a mile.
Does that make sense?
Yes, thank you.
Nice.
Yeah, good job, Mr.
Welcome.
Cook. I love how you used what you knew to figure out what you didn't know.
Going from the known to the unknown.
Very impressive.
Yeah, that's how we do
Good
it.
job, Henry. Good job working through that, buddy.
All right, Henry,
Excellent
you said
job,
you
Henry.
had one more question?
Oh, that's right. He had 2 questions.
I think
It's pretty confusing.
It's confusing.
Yes, very.
Okay, go ahead. What is it? Give us a try.
So it says little snail can crawl 1/4, 1/3, 3/4, and 7/8 of a mile a day. How far can he crawl in 5 days if he crawls the same distance?
I got to get a closer look at this one.
yeah. So I tried to write the numbers down quickly as you were saying it. So you said the little snail can crawl 1/4, 1/3, 3/4, and 7/8.
Of a mile a day, correct.
So he crawls all of these in one day.
Well, honestly, it's in apostrophe with commas in between each one.
Okay.
It's in parentheses with a comma between each one, so I'm not sure if we choose which one we want or if it's all of them a mile a day and we just add it up.
Oh, okay. So it's 1/4.
Uh-oh, don't break it
Mr.
again.
Tang, stop breaking the stuff!
Don't break it.
Sorry, guys. So 1/4, 1/3, 3/4, and 7/8. Is that correct?
Yes, that's correct.
All right. And so like read the next part of the problem again.
What? What?
What?
That's it. What?
What's the next part of the problem?
Oh, it says how far can he crawl in 5 days if he crawls the same distance each day?
Okay. So why don't we do this? Let's pick one of these distances that he goes a day, and then we'll multiply that out by 5 days. So which one do you want to do?
I'll take 1/4.
1/4.
All right. So our little snail travels 1/4 of a mile a day, right?
He's very
so
determined.
He goes 1/4 on the first day. And then he does the same thing the second day.
And
then
the
third day. And the
4th.
and one more day makes
The 5th.
5. So I'm guessing the problem is asking you to do this 4 different times. So we'll just do it one time for you, and hopefully you can do the rest of it, right? So we're working with a unit fraction here of 1/4, and we're going to add that to itself 5 times.
So
What's
then
another
it would be-
what's another way that we could write this using multiplication?
Well, we could do 1/4 times 5/1.
Yeah, so
Oh!
1/4 times 5, but you know that 5 wholes, another way to write that is 5/1, right?
Yep.
Smart kid.
So the answer will be the same if we do it either way. So if I like to add the unit fractions because to me that makes the most sense. If I have 1/4, I'm adding it to another 1/4, I have 2/4. If I have another 4th, I have 3/4. Another one is 4/4, and one more makes 5/4. Does that make sense, Henry?
Yes, so the answer is basically 5/4 or 1 and 1/4.
I love that. Tell the viewers here, how did you know it was 1 and 1/4? Because you're absolutely right. When we just did this together, we got 5/4. How did you know to change that to 1 and 1/4?
Well, if it's 5/4, so 4 is the denominator. So, but 5 is over that, so it would have 1. But then there's that it's 5/4. 4 goes into 5 once as 4, so then there's 1 more left, and that your denominator is 4. You would carry that over that, so 1 and 1/4.
Yeah, that's
Boom.
awesome.
Very
So,
good, Henry.
Yeah, you're absolutely
There
right.
you
So we
go.
knew that 4/4 makes 1 whole, right? So then we know that we can't have the mixed number, so we change it. We can't have the improper fraction, so we change that into a mixed number. So we have 1 whole and 1/4 left over.
Very nice.
Great job,
Right.
Henry.
All right, Henry. It was great talking to you. And
Thanks,
we will
Henry.
definitely send those prizes your way. Thanks for calling in, buddy. We'll talk to you soon, okay?
Bye-bye.
Thanks, buddy.
Bye.
Bye-bye. All
Ma-
right.
Max?
Ollie, who we got next up, man?
Oh, you guys ready for another caller?
Yeah.
Okay,
Let's
on
do
the
it.
phone now, we have Josue from Norwood Elementary, also in grade 2. Hello.
Hey, Josue.
Hi.
Hi, how's it going?
Good.
We're getting so many wonderful callers from Norwood. We're so
Yeah.
happy you called.
It's the Norwood Show.
Yeah.
Norwood homework helpers.
Okay, Josue, do you have a math problem for us?
Yes.
What you got?
16, 14.
It was a good year.
That was great. Easy. Done.
What else you got, bud?
Are we gonna?
14, 0 plus 17 equals.
Okay, so sounds like we're adding double-digit numbers. It was 16 plus 14.
I think it's 60 plus 14.
Ah, gotcha. Okay, perfect.
Yeah.
Josue, are we going to be adding 60 and 14? Is that correct?
Is that what we're doing, buddy?
Check the worksheet.
Yeah. That's
What we're doing.
We'll go for 20 plus.
Awesome. So what do we, when we're adding 60 and 14, I'm going to break 14 up into 10 plus 4. And 60 doesn't have anything in the ones place, so that can just stay at 60. Josue, what is 60 plus 10?
If you have 6 tens and you have 1 10, how many tens do you have altogether?
Your hot pocket might be done at the.
So 6 tens plus 1 10.
17, 14
Yeah, we got 70. Good. And then 70 plus 4. What's 70 plus 4, Josue?
equals 17, 14.
74. We don't want to have any extra numbers in the place value. We could only have one digit in each place value. So if you did line those numbers up, you might have seen that it was 70. And then we want to make sure that the 4 goes right into the ones place. Only one digit in the place value.
Josue, does that make sense to you, bud?
Yes.
Awesome, all right.
Good job, Josue.
All right, well, we're not done because we still have to tell you about what's coming your way, man, and it's lots of gifts and cool prizes. Woo!
Woohoo!
We got a lot being sent to Norwood.
Yeah. Speaking of which, Ollie, who do we got on the phone now, man?
Who is it, Max?
It is. I'm Tall. I'm Tall. You there?
Hello?
I am here.
How's it going?
Dad.
I can't believe it. We got another Norwood caller.
Wow.
Wow, what a cool school.
Norwood loves this, don't they?
I tell you
sure
what.
do.
So, Abdahal, what is your question for us?
My question is, in 130 below 5.
Say that one more time.
130 below 4. It's in 5.
All right, you guys are on that side of the wall, so good
All
luck.
right, so I'm sorry, Abtal, what'd you say? 130?
Yes, but it's on the very bottom.
The very bottom of, oh, you're saying on page 130?
Yes.
Okay, so is it the wagon question?
Yes. It's like 2 boxes.
Okay, so we did answer this one a little bit earlier, but
We can do the other
one.
We could do the other.
Another way of doing it?
Yeah, we did one set of numbers that made 27. We could do another set.
We could totally do that. So let's see. So for everybody else, we have Ben saw some wagons and trikes on the playground. In all, he saw 27 wheels. How many wagons and how many trikes did he see? So we're going to do it a little bit differently. Why don't we do, I'm going to start with the 27 wheels, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I know that's 10, so there's another group of 10.
Those are great wheels, Mr. Tang.
Thanks, buddy.
Really
and then
a
we
great
need
artist.
7 more to make 27. So 4, 5, 6, 7.
Where are the cars?
There aren't any cars. There's wagons and there's trikes.
Oh.
Okay.
Okay. So let's use a different color here. So we're just exploring with numbers here, guys. And this could be some fun. So we know that wagons have how many wheels, Abdahal?
27.
Well, you have 27 altogether with
That's
our
a good
wagons
point.
and our trikes, right? So how many wheels does a wagon have? One wagon.
4.
4.
That's right.
So let's see. 1, 2, 3, 4. So there's one wagon. How many wagons do you want to do?
7.
7 of them.
7 groups of 4. I think we're getting way too. That would get us to 28, I think.
That would be too
Yeah.
many.
Too many.
That would be too many.
Too many.
You want to do like another one or 2 more or how many?
Try at least one more.
All right, let's do one more.
That's a great wagon, Mr. Tang.
Thanks.
It looks like
red
a
for a
wagon.
red flyer, right? What's it called? Is it red flyer?
Radio flyer.
Radio flyer. Radio flyer.
But most of them were red.
True. Let's see. I'll tell you what. I see another group of 4 here. So that's another wagon. So we have 1 wagon, 2 wagons, 3 wagons. And I already know that I have another one here and another one here. I'm just going wild with the wagons here.
Those are great wagons.
So we have
just rolling
5 wagons. This is where we have to be careful. Because if I did another wagon, that would make 6. Can I do one more wagon from there?
Yes.
Well, that would be, we have 3 wheels left, right? So can I do one more wagon if a wagon has 4 wheels?
You could do a 3-wheel wagon.
I feel like we would fall down, right? If we tried to.
Yeah.
sit-
Is there anything
Bad
else
model line.
that has only 3 wheels that Ben could have seen in the problem? Was there anything else besides a wagon?
Wagons and
Yeah, we had the wagons and we had the
Something.
trikes. The
Trikes.
tricycles.
Oh, yeah, the trikes. We
And the
forgot about
trikes
the
have,
trikes.
how many wheels do the trikes have, guys?
How many wheels does how many wheels does a trike have?
3.
Yeah, 3.
Okay. So then we have 3 wheels left. That's perfect for 1 trike. I didn't mean to do it this way, but hey, we got to 27.
I think it's perfect.
Wait a minute, hold on. But I have a question.
Sure.
Does that mean you always had to do that many wagons and only 1 trike?
You don't always have to, because earlier we did we did the same exact problem.
Yeah.
Mr. Cook, do you remember how many wagons and trikes we had?
It was, I know
3.
that there had 9 trike wheels, and I think it was.
It was like 5 trikes. I think it was
And-
15.
Well, wait a minute. Can we try something? Because this is fun.
Sure.
Yeah.
Okay, can we do this again, but this time, can we see how many trikes we can do?
Oh.
And then we'll see how many wagons at the end of it, you know what I mean?
The
Kinda like
same
we did here.
strategy? The same strategy here?
Same strategy.
So this was 6 and 1. We could just hit the back button and clear all what you did, but leave the circles. Right?
Those are not
So-
circles, those are wheels.
Yeah, those
You're
are
right,
wheels,
you're
Mr.
right.
Cook.
I really
Please pay
should have said
attention.
that.
We're on live
Please
television.
stay
So
focused.
six wagons.
I'll write that
1
down
trike.
after you do that. So then it was 6 wagons and 1 trike got us to our 27 wheels, right?
Mm-hmm.
So what Max is suggesting is that we do the same thing, but we start with as many trikes as we can get. So let's see
Circle
if
the
that
3.
works. So we have 3 here, 3 here,
2,
3 here,
3,
and then another 3,
4,
3, 3,
5, 6,
3,
7,
3,
8.
and 3.
Oh, we have an even number.
So we got all 27 wheels and tricycles here.
Whoa.
And how many tricycles do we have? We have 1, 2. Ollie, were you keeping count, buddy?
Oh, yeah.
He was saying all kinds of numbers, I'm pretty sure.
Yeah.
Oh, so he wasn't helping us really?
Oh, he may have thought he was.
Yeah, it's 9.
Okay, thanks, Ollie.
Definitely even.
Yeah.
So we have 9 trikes
Just ask, you know.
with our 27 wheels. Do we have any more wheels for wagons?
Nope.
No.
We're wagonless.
So this couldn't be the answer. You know why?
Why?
Because the original problem said that we had wagons and trikes.
The invisible radio flyers. I don't think those existed back then.
So if you wrote the answer 9 trikes, even though that makes sense mathematically, it doesn't actually fall within the right parameters of what the question was asking.
Very cool.
Yeah,
Well, it
but-
was really cool just to see it anyway.
Yeah, I thought it was a lot of fun.
Yeah.
So
Well,
could we go that far, but now leave a multiple of 4 left?
Ooh.
Do you know what I'm saying? Like,
how would you do that?
so, if we backed up,
Is this a back button?
yes, to where before you were doing like, I know that if you took 9 and 8 away, that's 6. That's not a multiple of 4. But if you pause there, I think, because you had, I see what you did. You numbered it later.
Max,
Yeah.
you're in frame.
I'm in frame.
Sorry,
Focus.
Max.
You're good, man.
All right, so if we took away our 2 last trikes, we have 1, 2, 3, 4, 5, 6 wheels. That's not a multiple of 4.
Right, and I don't think it could be is it a
After
multiple of,
Maybe he could help us out. What are the multiples of 4? Can you skip count by 4 for us?
4. 4,
Uh-huh.
4, 8, 16,
There's
Almost
12
12.
and then 16. Okay, I think that's pretty good. That's good for now.
I think so.
So if we have 4, 8, 12, or 16, we know we have groups of 4 that we can separate this to. So right now we have 6, so that doesn't work. Actually, I have to go back again. So
We'll keep those in mind though, like 8,
4,
12,
8,
16,
12,
something like that.
16,
Yep,
yeah.
yep, yep,
A
yep.
That's what we're
multiple
looking
of 4,
for.
a multiple
Right.
of 4. So right now we have 6. If we take 1 more away, what's that?
Looks like 9.
9.
I think.
Not a multiple of 4
And
yet.
then another 3. Well, I think 3. That might be 12.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12.
There
So
we
now
go.
that we have 12, can we switch over from our trikes to our wagons now?
I think we can.
Let's start circling groups of 4 now.
All right. So we have 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4.
There they are.
Awesome.
There it
so
is.
What we can say, so another pattern that we have here is 1, 2, 3, 4, 5 trikes. which actually, Mr. Cook, I think that's what we actually had last time. And 1, 2, 3 wagons.
Look
It
at
may have
that.
been. So maybe there's only 2 ways, and we figured out both of them.
That's
did.
really cool.
That was awesome.
I tell you,
Sweet.
math is so much like a puzzle. You know what I mean? Figuring
Right.
out a puzzle. Awesome. Well, Abtahal, thank you so much for calling in, buddy.
Thank you.
And we'll send you some really cool prizes.
Thanks, buddy.
Bye.
Bye. Man, oh man. Hey, real quick, before we take our next caller, I got a question for you guys.
Oh, I love questions.
So, a couple callers ago, I think it was Henry from Riderwood, there was something you were doing with an improper fraction. Can you just explain a little bit to our callers and to me, because I'm a little unsure. What is that when you have an improper fraction?
That's a great question, Max. So fractions are partial numbers, right?
Gotcha.
I guess when we were in kindergarten and first grade, we were always told that numbers go 0, 1, 2, 3, whole numbers, right?
Right.
But then when we get to 3rd and 4th grade, we're magically told, wait, there's more.
Okay.
And so then we talk about these partial numbers. And I'm glad you asked that because something that happened earlier that we were talking about, it was like 1/2 of 3/4, right? Was that the question?
Yes.
And so like I love the idea of representing that using models, right? So we can use a pictorial here to show if we have 3/4 shaded in, how would you show one half of that? You could think of it as something like a candy bar.
You can slice it like horizontally.
Yeah, so let's go ahead and show that. So if we show 1/2 of that, so now instead of having 4 equal parts, how many equal parts do we have altogether?
Looks like there's 8 total parts and then 6 parts out of the total.
Yeah. So out of the 8 total parts, we have 1, 2, 3, 4, 5, 6. So that would be 6/8.
Oh, okay.
Is that what the answer was last time? Or?
What's going on?
Hello.
Hi.
Hello. Logan,
Hi,
what is
Logan.
your question for us today?
There are 12 fish in the tank. 5 are blue. The rest are red. How many fish are red in the tank?
Okay, I should say Logan.
Keep it professional, Mr. Cook.
We should. I know it's tough to keep. I don't do anything professionally.
True.
Logan, if there were 12 fish and 5 of them are blue, do you think we should draw a picture of these 12 fish and then color those 5 of them blue?
Sure.
All right, let's do it.
I love
have
coloring.
5 blue fish. 1, 2, 3, 4, 5.
Those are beautiful fish.
Right?
They look like
it
blue
sounds
potatoes,
a little fishy
but
though. I don't
okay.
know.
Potato fish.
If I continue, Logan, with this next fish, what number of fish is that? I got 5 blue, and then
What comes after 5?
6.
good.
There you go.
Ready? Can you count with me, Logan? I have 6, 7.
7, 8,
7, 8, 9, 10, 11, 12.
Good. I stopped there, right? Because there's 12 total fish.
Yeah.
Okay, excellent. So now, let's look back. I know that there were 5 blues. What do I do with the rest of it?
Add on.
Yeah, I'm going to keep adding on. Absolutely. Let's count up the red fish. I have 1,
1, 2, 3, 4, 5, 6, 7.
awesome. So 7 red fish and 5 blue. Logan, does 7 plus 5, does that equal 12?
Yes.
Oh, it does.
Excellent. So how many
go.
red fish must there be?
We just counted.
12,
12 total fish, and then how many red ones?
7.
7 red and 5 blue. Good job, Logan.
Very good, Logan. Hey, Logan, so you go to Honey Go?
Yeah.
And do you know Mr. Cook?
Yeah.
You see him in the hallways every once in a while?
Yeah.
Cool. That's great. So, Logan, Are you ready for something really cool? We got all kinds of prizes that are coming your way, including some slime. I bet your parents are going to love that, man. All right, buddy. Thanks so much for calling.
Thanks for calling.
Bye,
Bye,
Logan.
Logan.
Bye, Logan.
Bye.
Well, that was such a fun show.
was.
Unfortunately, it's got to close for the day.
No!
I know.
say
We got
it's
to close
not
it up
so.
today.
Well, we want to
Okay.
thank everyone for tuning in. And even though we're done for today, be on the lookout for our next round of Math Homework Helper Shorts, which will air right here on BCPS-TV and on our YouTube channel.
Yeah.
In addition, we will be back for another live show just like this one.
So in the meantime, keep working on your math skills, and we'll see you next time only here on BCPS-TV. Bye-bye, everybody. Bye-bye.
Bye-bye.